Hello everyone. The topic I am starting now is electrical energy and power. This topic now is very interesting. It is found in physics subject and also in the course of those studying electrical engineering. So those that are studying electrical engineering can benefit from this topic I am treating now. And those that are studying physics can benefit because this topic is taken from physics subject. So if you are writing an exam in physics, any exam at all that will involve physics subject, you need this topic because this topic is there. Then if you are writing an exam involving electrical course of any kind, this topic also needed. Okay, so I advise you to pay attention. Then I am also talking to our uncles, parents, and aunties. You can follow up, learn, and guide your younger ones, right? Now, I am going to treat electrical energy and electrical power. Now, this side is for electrical energy, and this side is for electrical power, right? Electrical energy is the ability of your electrical appliances to do work. Energy is the ability to do work. So electrical energy is the ability of the electrical appliances to do the work. The unit is measured in joules, and it has an interesting calculations. It is majorly of calculations, okay? And we have formulas that we use to calculate them. And the formula says electrical energy, let me use E to represent our electrical energy, right? For the sake of this topic I am treating here. Okay. Electrical energy is equals to I T V. That is the formula, okay? So let me explain this formula. E stands for electrical energy. I stands for current, electrical current. Then T stands for time, and V stands for potential difference, that is voltage, okay? Now, using this formula now, it says that electrical energy is equals to current consumed times the time taken for the electrical appliance to do the work times the voltage. Take for instance now you have electrical grinder, for example, and you want to grind something. It is the ability of this grinder to grind what you have put inside it to grind. And this electrical grinder now, we use current for it to do this work. The electrical grinder will now take time to do the work. And the electrical grinder will now need the voltage of the power of your country. Take for instance in Nigeria, we use 220 volts in Nigeria. That is the voltage of power in Nigeria. So if you bring your grinder now, for example, you look at the specification from the company. If the company has written that the grinder can be used in 220 volts, then it is usable in Nigeria. Now that is why you have to consider it in the ability of the grinder to do work. You understand? There are some countries that use 110 volts. So those countries that are using 110 volts, this grinder of 220 cannot work there. You understand? So that is why we need to consider it, because it is the potential difference that which the power station can supply current to the various destination. Now, the grinder now needs the current supplied by this power station with the help of the voltage, which can move, can push the current to different areas. So we now consider the current consumed, the voltage used, which is 220 in case of Nigeria, times time taken for this electrical grinder to do the work. So in calculation of electrical energy, it involves electrical energy equals to current consumed times multiplied by the time taken for this grinder to do the work times the voltage. It's applicable in any other equipment or electrical appliances, right? Then for power is the rate of doing work. Electrical power is the rate of electrical appliances to do the work, the rate. How fast these electrical appliances can do the work and how slow it can do the work. Remember, if it can do efficient work very quickly, it will consume small time. But if it is doing it slowly, it can consume a lot of time. So electrical power is the rate of doing the work. It is the rate of consuming electrical energy to do the work. So the formula we use to calculate electrical power is, let me use P to stand for the electrical power, right? It is equals to electrical energy all over time. Let me explain. It is the rate at which energy is consumed to a particular time of doing the work, to time consumed of doing the work, right? The same thing of the electrical grinder. The power of this electrical grinder depends on the energy of the electrical grinder to do the work and the time taken. It is the rate of this grinder to grind what you want efficiently at a time, whether it takes it a smaller time to do it quickly and efficiently, or it takes it a very long time to do it. So it is the rate of doing the work, the rate of consuming energy to do the work. Now, you know that E, which is electrical energy, has formula, which is the same thing as this one, current times time taken times voltage all over the time here. Which time here will cancel time down here. We now have only current times voltage. So you can now calculate electrical power using the current consumed times the voltage of the electricity, okay? Times the voltage of the electricity, right? Now, coming to this place now, this is electrical energy. And we know that current has its formula. The formula of current equals to voltage over resistance. That is the formula of current. Then we can replace this in this place. We now have electrical energy equals to, we now take away current and put this one. And when we put this one, we now have two V's because another V is here. It will now be V times V, which is V square, then times the time that is already there, all over R. So we no longer have I there. So you can calculate also electrical energy with this formula. Or we can also calculate electrical energy with another formula, which is voltage itself has its own formula. Voltage is equals to current times resistance. So now we now take this and replace it here. We now have, remember, if we replace V with IR, remember we now have another I, we have double I here, which means I times I will be I square, times the time that is already there, times the resistance. So now, we can now calculate electrical energy with these formulas, I, T, V, or we can also calculate it with V square T all over R. We can also calculate it with I square T R. Remember that this one is for current, time, and voltage. Voltage, time, resistance. Current, time, and resistance. Then from this, can you see that power is also current times voltage? And we have current and voltage here. So when we apply these two things here, which is here, we can now know that we can calculate electrical energy with power times time. We can calculate electrical energy by saying power times time can give us electrical energy, considering IV. That is also here, current times voltage, the same current as voltage. We remove it and put power. Okay? Then coming to power itself, we have power equals to IV, right? I has its own formula, remember. I is current, which is V over R. Then we now replace it. Remove this thing and put this one. And we have another V is here, which is double VIB. It will now V square. That's V times V square. We now have V square all over R. So this formula now can give us power. We can now say electrical power equals to voltage square times resistance. And the same thing, voltage has its own formula, which is voltage equals to current times resistance. We now remove it, okay, and put this. And if we put this, we now have double current, okay. It will now be current times current, which will give us current squared, okay, times R. So we can now calculate electrical power with current times voltage, or we can calculate electrical power with voltage square all over resistance, or we can calculate electrical power using current square times resistance. So my brothers and sisters and friends and well-wishers, this is the formulas we'll be making use of in our next video to give you so many calculations involving electrical energy and power. So make sure you are following, you subscribe to my YouTube channel and follow me on Facebook, Instagram, TikTok, and Twitter. And comment, share the video, like the video. Thank you so much as you do that. And thank you so much as you wait for the next video that will come with a lot of calculations involving this. God bless.